I'm gonna start recording. Okay, there we go. All right, so we're getting into our lesson today. We're gonna do a little bit of 9-2, and then we're gonna jump ahead to 9-3. I don't wanna do all of 9-2 today, so we'll come back to it later if I decide to. So you have your notes out. Let's see if I can find mine. There we go. Okay. I would like to get, if I can get to letter M today, that would be awesome. If not, we got through K the other day, so that's also fine. Sorry, I probably should have cleaned this up beforehand. All right, we're gonna be done with this page. We'll do that one. And then did we do any of number 3 in class the other day? Did we do 3A? Okay. Can I like re-go over that? Okay. I'm just going to completely redo it. If you have it done on your paper, awesome. But I'm just going to completely redo that one. I want to finish doing letter 3 or number 3, and then we will jump into section 9.3. I don't think I need a calculator yet, so I'll throw that away. Okay. So again, you guys probably have this done. I can't remember if I did it in the last recording. So if I didn't, YouTube, you guys can watch it again. If I did, you can fast forward through this. Does not matter to me. On this type of problem, we're still doing our binomial expansion that we were working on yesterday. We're still using our Pascal's triangle to figure out what my coefficients are. But in this case, I don't want to do the entire binomial expression, expand it out. I just want to do one term. So in this case, we're just going to do the 4th term. I mean, you saw how long it took us to do x plus y to the 5th. It would take us so much longer to do x plus y to the 10th. So instead of doing it that way, we're going to just work it out just that single term instead of the entire expression. Okay, if you remember, the way we started was I wanted to go to the 4th term. So I counted off 1, 2, 3, 4 spots. And I asked, okay, what does my x term, what is my x when I'm in the 4th term? Well, we know that the x's, do those go up as you go across the page, or do they go down as you go across the page? Down. So they're going to go down as I go across the page. So that means I'm starting with x to the 10th, and then I go down x to the 9th, x to the 8th, and then x to the 7th. So I only care about this 4th spot. So I put x to the 7th. That's all I care about. We use that number, that exponent, to help me figure out. I use that exponent to help me figure out what my coefficient of this term is going to be. Remember that we're doing NCR here because we're choosing a number. 10 goes for my N. I use C because it doesn't matter the order. And then R is my exponent of the X in the 4th spot. We want it to be 4. It's not going to be 4. So I just want to like tell you, we all want the number that we all want R to be 4, and it's not 4. Instead, it's 7. It's whatever the exponent of the X in the 4th spot is. Yeah. So what happens is this Pascal's triangle is based on like picking or like the probability of having like a certain number. You know how we've been choosing like 10 to 7 is like what's possibilities of picking 10 people for these 7 spots. That's what we're doing here. These numbers are modeled after that, and we can find them easily when it's from the 0 to the 5th power, and maybe even the 6th or 7th. But by the time we get to the 10th, that's a lot of work to get this coefficient. So instead, kind of the shortcut or the mathematical like way behind it is using NCR. Yes. So we're going to use NCR here. So 10C7. Next thing I want to do is put my X term. So what was my X term here? X to the, good. And then my Y term is going to be raised to the what power? Y. They add up to 10. Good. So if I count down, I like to count down one of them. I like to count down my X's. And then I use, okay, 7 plus what equals 10. The exponents have to add up to be whatever the power I'm raising it to. Now this is easy because I don't have to do anything. Like I don't have to actually raise x to the 7th because that's as simple as it gets. I don't actually have to do anything with the y to the 3rd because that's as simple as it gets. The only thing I do have to do is put my 10C7 into the calculator and figure out what that is. So let me pull my calculator back out. Oh, math, NCR, 10C7, and I get 120. So I'm going to say 120 x to the 7th, y to the 3rd. All right. Let's do this again, but on the next problem, I actually have like coefficients and I've got different numbers with my x's and my y's. So we're gonna have to deal with those as we go. You ready? Okay, so now this one says we wanna do the 3rd term of 2x minus y to the 7th. Okay, so I gotta figure out which term I want. 1, 2, 3. I'm gonna use my x's and we go down as we go across the page. So my first term would be 2x raised to the 7th. And then I'd go to the next term, the second term, that'd be 2x raised to the 6th. And then I would go one more, 2x raised to the 5th. Very good. So that's the term, bless you, that we care about. Okay. Now what? 7C5, very good. So that'll be my coefficient. Now I got to deal with my x. What's my x? Good. I'm going to just go one step slower than you, Curtis. I'm going to do 2x raised to the 5th, and then we'll get there. And then what's my last term? What's my y term? Good. Carry that negative with you because normally it's a plus sign in between those, so that negative matters. So make sure you carry that negative with you. Negative y raised to the 2nd. Okay. Questions, concerns yet? Okay, let's do 7C5 to find my coefficient. Math. Scroll over to the PRB, the probability menu, and then number 3 is NCR. 7C5, and I get 21. Ooh. Now I'm ready, like Curtis said, to do 2 to the 5th and x to the 5th. And what did you tell me 2 to the 5th was? 32, x to the, bless you, 5th. And then what's negative y squared? Y squared. Why does the negative go away? When you square -1, we get +1, right? All right, so now I multiply my 21 times my 32. I throw my x and my y on the end. 21 times 32, and I get 672 x to the 5th, y squared. All right, that wasn't too bad, was it? Okay. We are not gonna do number 4, 5. We will never do 6, I'm gonna be honest. We're not gonna do 4 and 5 today. I did not come prepared enough on that, and I wanna make sure I'm really good on it before I start instructing you on it. So I think I've told you that probability is like my least strong part of math. It's what I feel like the most uncomfortable with and self-conscious about. So I really want to like make sure I'm like good when I explain things to you, because if I start second guessing myself, it's not going to be good for you guys, right? So we're going to skip that for right now. But I feel good about 9.3. So let's skip to 9.3. If you can though tonight for your homework, I want you to do the first 2 problems on 9.2. So do the 2 that you can do, the 2 that are binomial expression that you have an example of. So you just have 2 problems for homework for Monday. That's not bad, right? Awesome. Okay, so getting our 9.3 homework out. Bless you. our 9.3, or not homework, I'm so sorry, our notes, get your 9.3 notes out. And we are now talking about probability. So I think I've told you that this unit is called probability, but we haven't really talked about it yet or really defined it. So let's talk about what probability means. Probability is the number of successful outcomes over the number of total outcomes. Let's actually do some examples with that. What would be the probability of, like when you do a coin toss before a game, what's the probability that you would win? Probability. How many times are you successful? What'd you say, Maria? 1 to 2. So probability is 1 to 2 because you're going to pick one of them. You're going to pick heads or tails. I always like to say heads. And then there are 2 possible answers, heads or tails. So the number of success is 1. The number of total things that could happen is 2. So that's my coin. What about if I was rolling a dice?
1 to 6.
1 to 6. Good. So rolling a dice, if I said, okay, what's the probability of you rolling a 2 on the dice? Well, there's only one side that's a 2 and that there are 6 sides total. So that's a 1/6 probability that you will get the correct thing. Okay, now what's different is odds. And I personally have like a really hard time with odds in my head. Some people don't. I, for some reason, just like struggle with the concept. Odds is the number of success or successful outcomes over the number of failures. So Parker, a minute ago, you gave me the odds, not the probability.
50-50.
50-50,
So
except
is that more like percentages then?
I would even bring it all the way down to a 1/1 instead of a 50-50. That is kind of percentages because you're like 50% chance you win, 50% chance you lose. That's what odds are. Odds are how many times could you be successful versus how many times could you fail. So in a coin toss, if I say heads, I have 1 chance of winning and I have a chance of losing, right? So that's a 1-to-1 ratio. If you would prefer thinking about it as a ratio instead of a fraction, go right ahead. Now with a dice, what's the odds that you'll get a 2?
1 to 5.
1 to 5. Again, if you want to make it a ratio instead of a fraction, go right ahead. So personally, I struggle with odds, but some people do fine with them. I mean, if you do any kind of betting, gambling, etc., like they talk in odds all the time. I just, for some reason, cannot wrap my head around it. So, but that's all right. We're going to do a lot more probability than we are going to do odds. So we are all good over here.
So for odds, you take away 1.
You would take away how many successes from the total. So like if we think about it like 1/2, I've got 1 success. And so I do 2 minus 1 to get my failure. Same thing over here. This time we just happened to do the same thing. We were just had a one option of winning versus all the options of losing. So this time it was just 1, but normally you take the number of success minus the net total. All right, now we're going to use a chart to answer some questions. So I'm talking about a girl named Maggie. She has a bag of M&Ms, and a girl named Elizabeth who also has a bag of M&Ms. Each girl counted her M&Ms and has discovered the following proportions of each color of candy in their respective bags. Oh, hi, Chris. And we have a chart here now. So what this is saying is that like of all of her M&Ms, 0.3 of them are green, 0.2 are yellow, 0.2 are red, 0.2 are brown, and then 0.1 is blue. How many is that all together? It would be 1. Yeah. If they didn't have decimals, it would be 10. But since I do have decimals, it's 1. You can think of these in your head as percentages if you want. This is 1.00. So that would mean this is like 30%. That's a weird 3. Pretend that says 30%. Jeez. I'm a little bit more together. Our A period the other day was like off the rails for all of us. I'm a little bit better today, but that was a wild 3. Okay, 30%, 20%, 20%, etc. I'm going to keep it as decimals as I'm doing the work, but at the end, I'm going to give it as a percentage. If you want to do a fraction, that's fine. If you want to keep it as a decimal, that's fine. If you want to do a percentage, that's also fine. For some reason, my head likes percentages better. So if there's something that fits your head or you just go to naturally, go ahead and keep it there. And I will do my best to make sure if you're doing the equivalent thing, you'll get all the right points. Elizabeth has the same concept, but she has slightly different ratios. So 0.2 for green, 0.2 for yellow, 0.3 for red, 0.1 for brown, and 0.2 for blue. So we are going to use this chart and we're going to answer all of the following questions. So letter A, it says, if a candy is chosen from Elizabeth's bag, what's the probability it will be green? Okay, so I'm looking at just Elizabeth's bag and we have a column that says green. And so what's the probability that she will get a green one? What'd you say? 20%. You can go even as basic as 0.2. You can say that's the same thing as, what is that, 1/5? Or I like 20%. Those are all the same answer. Bless you. Need a slightly bigger pencil. What about the next one? If a candy is chosen from Maggie's bag, what's the probability it will not be yellow? So that means it could be green, red, brown, blue. Chris, you said 80%. What'd you do to get that? Good. You guys told me a minute ago that the total is 1. So if I know that the total is 1 and it's 0.2 probability or proportion of being yellow, so I'm going to minus those off and I'm going to get 0.8. You also can think about, okay, well, we'll add 0.3 plus 0.2 plus 0.2 plus 0.1. You can add all the yes options, or you can take the total and minus the no option. Again, if you want to make that a fraction, it can be 4/5. If you want to make it a percentage, which is probably what I think in my head, it's going to be 80%. Okay. If a candy is chosen from each bag, what's the probability that they will both be red? Okay, so we have to look at both bags here. So probability it will be red for the first one. In Maggie's bag, what's the probability it will be red? In Maggie's bag, 0.2, good. And in Elizabeth's bag, 0.3. We are going to take those and we are going to multiply them together because we're taking 1 from each bag. We're doing 1 from Maggie and we're doing 1 from Elizabeth. We want both of them to be true, so we are going to multiply. Remember, anytime we see and, we're going to multiply. So 0.2 times 0.3, which does anyone know what that is? 0.06, good. A bunch of us want to just say 0.6. You have a calculator, when in doubt, you can use it. And that's the same thing as 6%. Everyone good? All right, next one says, if candy is chosen from each bag, so I'm doing the exact same concept, Maggie and Elizabeth, what's the probability that neither will be brown? Well, what's the probability it won't be brown from Maggie's bag? What's the probability? 80%. It will not be brown from Maggie's bag. How did you get that, Chris? Good, so Chris said, I know from 1. Yeah. I almost let it go and I was like, no, I gotta say that. So he did 1 minus how many brown we have. So 1 minus 0.2 is 0.8. And then what's the probability it will not be brown from Elizabeth's bag? 0.9, because I'm gonna do 1 minus 0.1. So 0.8 times 0.9, and that's 0.72, which is 72%. It's a pretty big percentage. If a candy is chosen from each bag, again, same concept as before, what's the probability that the first one will be green and the second one will be blue? We're going from Maggie's to Elizabeth's. Yeah, Drew.
Going back to D.
Yeah.
Could you just multiply with the browns from each and then just subtract it off?
Well, let's see. Could we? If we multiply the browns from each, so 0.2 times 0.1. That gives us 0.02. And then can we minus that from 100 or from 1? Wait. I don't think that will work. I'd want that to work too, Drew, but I guess it doesn't. So I guess we have to just do the not browns. I feel like that should work though. Let me come back to that and report back to you, okay? Because I feel like that you should be able to do that, but maybe not. Okay, so it says a candy is chosen from each bag. What's the probability the first one will be green and the second one will be blue? So we're gonna go from Maggie's bag first because that's how we've been choosing. What's the probability the first one will be green? Well, what's the probability we get green from Maggie? What'd you say? Yep, 0.3. And then what's the probability the second one will be blue? So we get a blue from Elizabeth? 0.2. So we're gonna say 0.3 times 0.2, which we've already done is 0.06, which is 6%. Okay. Everybody hanging in there so far? All right, next one says, what's the probability that one will be blue and one will be green? Since it doesn't say the first one and the second one, it just says one of them will be blue and one of them will be green. We have to think about going either way. So I have to think about, well, what if we chose green from Maggie and blue from Elizabeth? Well, cool, we just did that probability, right? So I'm gonna keep that 0.3 times that 0.2. However, this time it just says we need a green and a blue, so it doesn't matter what order we plug them in. So I'm gonna have another set of probability. That's what happens if I get a green from Elizabeth and a blue from Maggie. What's the proportion that I would get a green from Elizabeth? 0.2. And what about blue from Maggie? 0.1. So I'm going to do 0.2 times 0.1. These are two different situations. One with Maggie first and Elizabeth second, one with Elizabeth first and one with Maggie second. I'm going to add those two numbers together. So I'm doing 0.3 times 0.2 added to 0.2 times 0.1. Okay. So I get 0.06 and I get 0.02, add them together to get 0.08, which is 8%. Last one. If a candy is chosen from each bag, so we've been doing the same type of problem over and over, it says, what is the probability that neither will be red? So what's the probability it will not be red from Maggie's bag? 0.8, because we're going to do 0.1 minus 0.2. And then what about from Elizabeth's bag? What's the probability it will not be red? 0.7. 0.8 times 0.7 is 0.56, which is 56%. Okay. So in all of those problems, we use charts to help us solve. Okay, everybody okay with that so far? Okay, the rest of the problems we're doing today are all using the same concept. We're talking about decks of cards and dealing a 5-card hand. So we're going to do a little team timeout. We're going to talk about decks of cards. This may feel super elementary to you, but I had a student a few years ago who tried to argue with me about how many cards were in a deck and how many suits there were. And then she tried to tell me that I didn't tell her how many suits there were. And I said, I thought that was information you came to my class with. And she argued she didn't know. So we're gonna go over some basics of cards. You guys ready? Do you have any card sharks in here? It was years and years ago, 2018. Anybody like to play card games? Let's play cards. Who plays euchre? Any other card games we play besides euchre? BS. Blackjack. BS is such a fun game. I forgot about BS until last week, and I was like, oh, that was a fun game. What'd you say? Slapjack. Spoons. Texas Hold'em. War. Did anyone play, what is it called? RES, where it's a 2-person game? Yeah. Egyptian rat screw, yeah. What'd you say? Yes. I was talking about temps. All right, anyway, we know some cards, right? Okay, so hopefully this is gonna be easy for us. So how many cards are there in a deck? 52? Okay, I think you said 56. I'm not gonna count any jokers. We're just gonna count normal cards that we play with. So that's total.
What's the informational part of the front?
Don't be like this. Okay, how many suits are there?
4.
4. How many colors are there?
4. Or 2.
2. Maybe we did need to go over this. How many like different kinds of cards are there? Those are, I think, 13. So I'm going to count all the numbers 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'm going to count Jack, King, Queen, Ace. So I think 13. Yeah, I didn't count 1. Yeah, okay. I'm not arguing with high schoolers today. Sometimes I have to wake up and tell myself I'm not arguing with an 18-year-old today. All right, and I think, Maria, you said this a minute ago, there's 4 of each type of card, right? So there's like 4 4s, there's 4 jacks, there's 4 aces, there's 4, I'll say maybe I'll rephrase that. I'll say 13 types. I can't really think of another name for that. 4 of each type. And then the only other thing I think that I want to mention is face cards. How many face cards are there? I'm going to argue only the ones with actual faces on it. So I'm only going to argue Jack, King, Queen are face cards. Jack and Joker.
I said the wrong thing.
So how many Jacks, Queens, and Kings are there? I think Rocco told me 12. Yep, very good. So there's 12 face cards. I know everyone gets a little funky about the aces, but we are not going to count aces as a face card because aces do not have faces on them. I know sometimes they have.
Face.
Say again?
Face no face.
Okay. Parker's a little bit on one today. Okay, so those are important things that we're going to deal with in all of these problems. Okay, but the first one that we're doing is the most important because it's going to help us do probability for all the other ones. It says how many 5-card hands are possible. So we can't really call this euchre because in euchre, you know, you take out a bunch of cards. Is there like a poker game that you play with 5 cards in your hand? Well, okay, we're going to assume that we're playing that game, okay? So how many cards can you get? How many total cards are there that you could get? 52. Someone said 56 and now we're all bent out of shape. 52 total cards that you could possibly get. And how many do I want? 5. Okay, now the letter in between is either P or C. Does it matter which order you get the cards? Does it matter if you get the ace first or the 4 first or the jack first or the, no, right? Because you just pick it up in your hand and then most of us shuffle it around, right? So that we have all the same suits together or you put it in number order. Like we have a reason that we put our cards in our hands in a certain way. So it does not matter what order we put it in. So we're going to say C. So I'm going to say 52 C5 are all the possible hands that you could make with 5 cards in your hand. Let's actually do that in the calculator, see how big or small a number that is. 50, or let me go math, NCR, 52 C5. Ooh, that's a big number. Is that 25? No, too many. I lost a decimal. 2,598,960. It's a lot of times, a lot of different combinations. So people like to play cards because there's a lot of possibilities out there. Okay, now all of these problems after this say, what is the probability? What is the probability? What is the probability? What is the probability? If you go back up above, remember that probability is success over total. So my total is always going to be this 52C5 because those are all of the possible options. The numerator, the number of successful things will depend on what the problem is actually stating, but all of my denominators are going to be this 52, choose 5, okay? I actually don't need my calculator because I'm not going to plug any of these in. I don't really want a number. Actually, it's easier for me to grade and to know what you guys know if we leave it in the kind of simplified math form. All right, so next problem. What is the probability of being dealt a hand with all diamonds? How many diamonds are there in the deck? 13, and we want how many? A hand, which is 5. So 13, choose 5. That's all of my success. And then my denominator is all the total, which is what we found above, 52, C5. And I actually am good with the answer being left here. 15 or 13, choose 5 over 52, choose 5. Cool. That's not too bad, is it? Can we keep going? All right, flip your paper over. What's the probability of being dealt all face cards? Well, my question is, how many face cards are there? Total 12. So we're going to say there's total 12. And how many do I want? 5. 12, choose 5 over 52, choose 5. Good. And yeah, never mind. I was going to explain something I don't think I need to. All right, what's the probability of being dealt an all red hand? Not 24. 26. 26. How we get 26? 13 times 2 or 52 divided by 2. Yep, both things are possible. 26, choose 5 over 52, choose 5. Ooh, this next one's fun. It says, what is the probability of being dealt a hand with 3 jacks and 2 kings? Okay, so let's break it apart. How many jacks are there? 4. How many do I want? 3. 4, choose 3. There are 4 total. I want 3 of them. It's going to be times because it says and. And also they're in the same hand. So since I want them all together, I want it in the same hand, I'm going to multiply it together. If I want 2 separate hands, which we might get to today, we might not, then I don't want to do it that way. Now I want 2 kings. So how many kings are there? And how many do I want? Ooh, 2. 4, choose 2. Good. And I don't even need you to simplify it. That's fine as it is because I can see in your head, I see, okay, you knew there were 4 jacks and we want 3, and there are 4 kings and you want 2. Like I can physically see your thought process by looking at this. And all over 52, choose 2. Or choose 5. Choose 5. All right, what's the probability of being dealt a hand with no face cards? How many are not face cards? What'd you say? That's how many are face cards. 40. How'd you get 40, Chris?
12.
52 minus 12. So the total is 52. We have 12 face cards minus those 12 off. We get 40. So if I want no face cards, if I want all numbers and aces, I'm going to do 40, choose 5 over 52, choose 5. Okay. Doing okay so far? All right, letter G says, what's the probability of being dealt a 5-card hand and having all of the aces? How many aces are there? 4, and how many do I want? Can I have 5 though? Nah. Never. How many can I have though? 4. So if I want all of the aces, I can only get 4 aces. Another little hint, if you find yourself trying to write a bigger number for the second one, it's wrong. There will never be a bigger number second. The bigger number is always first because that's all the total. And then the next one is how many I want. This time it just happens that there are 4 and I want all 4. Now, how many more cards do I need in my hand? Because I still have to have 5 cards, right? I just need 1 more card. Does it matter what that next card is? No. How many cards are left that I could get? 48. So hopefully I've gotten all the aces already. And then I don't care any other card I get will be 48, choose 1. And that's another multiply because I want all the aces, and then I have to have another card because I can't just have 4 cards in my hand. I need 5. And that's going to be over 52, choose 5. All right, what's the probability of being dealt a 5-card hand, and having 2 10s, 2 jacks, and 1 queen? Okay, let's break it apart. What's the probability of getting, or sorry, how can I get 2 10s?
4 choose 2.
4 choose 2. How can I get 2 jacks?
4 choose 2.
Okay. And how can I get a queen? 1 queen.
4 choose
4 choose 1. They are all in the same hand. I need both my kings, or both my jacks, both my 10s, and my 1 queen. And so they're all being multiplied together. And then they're being divided by the total, 52, choose 5. Okay. Doing okay? All right. What's the probability of being dealt 5-card hand with no aces, no queens, and no 5s? How many cards do I not want?
12.
12. Why is it 12?
Because there's 4 aces, 4 queens, and 4.
There's 3 types of cards I don't want. There are 4 of each of those types. So that gives me 12 that I do not want. I do not want, bless you, 12 of them. So how many are okay for me to have? 40. So how would I represent that? 40 choose 5 over 52 choose 5. All right, what's the probability of being dealt exactly 4 spades? How many spades are there? 13? How many spades are there? So there are, so spades is a suit. There are 13 of each suit. So I want 4 of them. Am I done?
No, you need to add 48 more. Or no. It's the 48 change.
I need a 5-card hand. Remember, all of these are 5-card hands. I only want 4 spades, though. Something, choose 1. Why is it 39, choose 1? Minus 13, 52 minus 13. And so then 52, choose 5. All right, let's look at letter K. It says, what's the probability of being dealt at least 4 spades? Okay, so we have to figure out what is okay and what is not okay. So what is okay? What do I want?
4 spades.
I want 4 spades. What else is okay?
5 spades.
5 spades. What else is okay?
That's it.
That's it. Okay, so what's not okay? 3 spades or even 0. So I'm going to focus on what's okay. So I'm going to actually have to do a couple different things. So I'm going to have 2 hands kind of in my numerator. Let's do the probability of getting 4 spades. Didn't we just do that a second ago? We just did. So the one above said the probability of being dealt exactly 4 spades. We just did that. So if I want 4 spades, if 4 spades is okay, then it can be 13 choose 4 times 39 choose 1. Okay, so that handles my 4 is okay. Now I want to know how many options can I, let me rephrase that. How can I get 5 spades?
13 choose 5.
13 choose 5. When I have 2 hands in here, so it's okay if I have 4 spades and 1 extra card, or it's okay that I have 5 spades, I'm going to put a plus sign in between them. So anytime I'm doing like all the things for 1 hand, I'm going to multiply them. So like the last couple, like when I did 2 10s, 2 jacks, and 1 queen, that was all in 1 hand, so I multiplied it. If I want 4 spades in another card, that's all in 1 hand, so I multiply it. If I had all the aces and another card, that's all in 1 hand, so I multiply it. This time, though, I'm saying I want 4 spades or I want 5 spades. Both of those are okay with me. I'm fine. Everything's good. So I'm going to do a plus in between them. And on the bottom, it's still 52, choose 5. Okay. Letter L is similar. It says, what's the probability of being dealt at most 4 red cards? So what's okay here? How many red cards is okay? 0, 1, 2, 3, 4. Is 4 okay? Yeah. What's not okay? 5. Okay. Now, what we could do, like, see how the last one we did the okays and we had to do like this hand plus this hand? If we did all the okays here, we'd have to say, okay, what's the probability we get 0 red cards? What's the probability of getting 1 red card? Plus, 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 plus. What if we did instead the no's? What if we just did, okay, what's the chance that we get not a 5? Yeah, that would be a lot easier. But we need to do 1 minus whatever that is going to be. Remember how the problem above in the chart, how we did 1 plus or 1 minus those things? 1 is the total. Or in this case, 100% is the total here. When I'm doing my probability, 1 is always what we're adding up to be. So what's the probability of getting 5 red cards? 26, choose 5 over 52, choose 5. You got it. You got it. Is everyone okay with why I did 1 minus that? Because I really wanted everything but that. And this was the easier one to find. So to get all of these things as okay, I had to do the total minus just the one case that didn't work. All right, the very last one we're going to do today, it says, what's the probability of being dealt 2 of one suit and 3 of another? Okay, so let's see. Okay, what's the probability that, let's put names to these suits. Let's say, what's the probability of being dealt 2 hearts? How many hearts are there? Bless you. 13. Choose how many? Good. And then what's the probability we get 3, I don't know, clubs? 13. Choose 3. All right, all over 52. Choose 5. Okay, now I had to pretend to tell you what suits to do in order for that to kind of make sense in our head. That being said, we have to do one more additional thing here in order to show we're doing 2 of one suit and then 3 of another. So out front, I'm going to do what's the probability of us picking 2 suits. Okay. So it's essentially thinking about, okay, I have 1 suit I want first and then 1 suit I want second. I picked hearts first, but how many did I have to choose from? 4? Not factorial 4, because I only want 2 spots. Give me 1 second, you're almost there. Okay, so I picked 4. There were 4 things to pick, and then I picked hearts, and then I had how many options to pick clubs? 3. Okay, I just want 4 over 3. However, does it matter if I say, what'd you say? He is right. Does it matter my order?
Yes.
Yes, because if I only want 2 of the hearts and 3 of the clubs, that's not the same thing as 2 clubs and 3 hearts. You agree with me there? So it matters that I'm doing hearts first and then clubs. And that's different than if I did clubs first and then hearts. So I'm going to say 4P. Did you say 4P3? It's 4P2.
Oh, no.
Yeah, question.
Okay, so
Where did I get the 2 what?
is it like, you know how you said 26?
Oh, can I finish M really quick?
Yes.
I'm almost done. The only thing I want to do is instead of putting 4P2 out front, I want to put a real number. So let's figure out what 4P2 is. I already had to have the work done. It's 4 times 3, which is 12. So I'm going to put 12 out front because that tells me all of the possibilities to get all my suits, one and then the other one. Yeah, Cam, questions on M? It's 4P2 because it matters if I did hearts first or if I did clubs first. because I only want 2 suits. Question on M?
Yeah. Why does order matter if they don't give us a specific suit?
We're doing new bells today, so that's like the minute bell. Say again.
Why does order matter if they don't give us a specific suit?
Because it matters if I did hearts first or if I did clubs first, because I only want 2 of one card and then 3 of the other card. So it's different if I get 2 hearts and 3 clubs, or if I get 3 hearts and 2 clubs.
So if they were both 3,
I just wouldn't matter.
Yeah, if it was both the same number, it wouldn't matter.
What do you mean both the same number?
If it was like 2 and 2, it wouldn't matter which one you had first.
Oh, okay.
But since it's different numbers of each.
Okay. That makes sense.
All right, if you are finished, you are free to go. Remember, you have 2 problems of homework to do for Monday. Maria, what was your question on number M, letter M?
Yeah, what's up with the one?
Or 26 because it's red cards. And so there's 2 colors of the deck, red and black.
So this is how we make this more. How do we make this end of the school
Yeah, which
more
is
weird?
26. That's okay.
I was thinking in terms of the 13.
You could do 13 times 2 to get 26 because 2 suits are both red. So 13 times 2 would give you that as well.
And then I did